The worst-case scenario for the interstellar object known as 3I Atlas sounds like science fiction. That is, until you truly give the idea room to breathe. What if it's not leaving? What if this flyby trajectory, this graceful arc through our solar system, is actually a deceleration maneuver executed by technology so advanced we can't even detect its mechanisms? Imagine an intelligence so profound that mimicking natural orbital mechanics is child's play. A civilization that deploys its surveillance assets disguised as the cosmos's most common features: comets, asteroids, even harmless space debris. From this perspective, 3I Atlas's unprecedented speed and impossible chemistry might not be signatures of alien formation, but of alien intention. As it approaches its closest point to the Sun, its perihelion hidden systems could be powering up, preparing for the next phase of whatever mission brought it here. Tonight, we'll venture into these speculative shadows, places where comfortable, natural explanations begin to crumble, and a deeper, more cosmic paranoia can take root. The question, in this realm of thought, isn't whether 3I Atlas will leave. It's whether we will recognize the moment it decides to stay. The fundamental question, the one that sparks both scientific curiosity and primal fear, is simple. Is 3I Atlas a threat? On July 1st, 2025, Chile's Atlas telescope detected something extraordinary. A speck of light with a trajectory so extreme it could only mean one thing. This visitor came from another star system entirely. Designated 3I Atlas, it became humanity's third confirmed interstellar object, following the mysterious Oumuamua in 2017 and the more conventional Comet 2I/Borisov in 2019. But what if this third visitor carries implications far beyond the first two? Implications that stretch the very definition of worst-case scenario? Unlike the native objects of our solar system, bound to the Sun by elliptical orbits, 3I Atlas traces a hyperbolic path. Its orbital eccentricity is greater than 1.0, marking it as definitively unbound, a traveler just passing through. It raced inward from the direction of the constellation Lynx at speeds that defy imagination, scheduled to reach perihelion on October 29th at over 130,000 miles per hour, fast enough to cross the continental United States in under 3 minutes. Yet, beneath these reassuring mathematical certainties, a nagging question persists. What if the true worst case isn't about where it's going, but about what it might reveal about us? Despite this dramatic velocity, NASA's position is unequivocal. 3I Atlas poses absolutely no threat to Earth. Its closest approach in mid-December will be approximately 1.8 astronomical units away, about 170 million miles, nearly twice the distance between Earth and Mars at their closest. The numbers are clear, but when we venture beyond NASA's careful language into the realm of speculation, what shadows might this ancient wanderer cast on our assumptions about intelligence, purpose, and cosmic coincidence? The global astronomical response has been swift and thorough. The Hubble Space Telescope has been monitoring the visitor since its discovery, revealing classic cometary behavior. Solar radiation sublimates ices within its nucleus, creating a glowing coma. The James Webb Space Telescope captured its spectra on August 6th, showing unusually high carbon dioxide concentrations, a chemical signature speaking of alien formation conditions unlike anything common in our solar system. This chemical oddity raises an uncomfortable question. What if 3I Atlas's true significance lies not in what it is, but in what it forces us to confront about what we don't know? Radio telescopes have scanned it, finding only natural emissions and silence where artificial signals might hide. This coordinated effort represents modern astronomy at its finest, confirming the object's interstellar origins and its harmless trajectory. As The Guardian aptly noted, 3I Atlas is a cosmic curiosity, not a catastrophe. A reminder that we inhabit a universe far stranger and more connected than daily life suggests. This ancient visitor offers us a brief window into galactic deep history, carrying secrets from stellar neighborhoods we can barely imagine. But what if the real mystery isn't what secrets it carries, but what secrets it might unlock about the true nature of interstellar visitors and the speculative scenarios that lie beyond the reach of our finest telescopes? The raw data surrounding 3I Atlas alone is enough to stagger the imagination. It is a quiet powerhouse, a testament to the violent and dynamic nature of our galaxy. Its speed is its most defining characteristic. At over 130,000 miles per hour, it moves roughly 150 times faster than a high-powered rifle bullet. Its hyperbolic excess velocity, the speed it maintains even outside the sun's gravitational influence, is a blistering 61 kilometers per second. This velocity dwarfs its interstellar predecessors. Oumuamua traveled at 26 kilometers per second and Borisov at 32 kilometers per second. 3I Atlas moves nearly twice as fast, suggesting either a violent ejection from its birth system or a long, complex history of gravitational slingshots around multiple stars during its cosmic odyssey. Determining its true size, however, proves challenging. The glowing coma that makes it visible also obscures the solid nucleus at its heart. Current estimates range wildly, from 0.3 to 5.6 kilometers in diameter, anywhere from 3 football fields to a small mountain. This uncertainty stems from assumptions about its surface reflectivity and how efficiently it produces its coma. The smaller estimates seem more likely, but even at 0.3 kilometers, we're discussing a substantial piece of cosmic real estate. This very uncertainty raises fascinating questions about survival. How could such a relatively modest body endure the violent ejection from its home system, followed by millions or perhaps billions of years in the cold, radiation-drenched void of interstellar space? Smaller objects face greater vulnerability to tidal disruption and high-speed impacts with cosmic debris. Most intriguingly, 3I Atlas likely possesses extreme antiquity. Dynamical analysis suggests origins in our galaxy's thick disk, an older stellar population from when the Milky Way was young, chaotic, and still assembling itself. If correct, this visitor could predate our entire solar system by billions of years, carrying within its frozen nucleus pristine records of galactic evolution from when the universe was less than half its current age. Despite its tremendous speed and mysterious history, the orbital mechanics are clear. 3I Atlas poses no dynamical threat. The same hyperbolic trajectory that marks it as an interstellar visitor also guarantees its safe passage. It moves too fast for solar capture, and its closest approaches are measured in comfortable astronomical units, not worrisome kilometers. But as we prepare to explore the shadows beyond scientific certainty, we must ask, what if the real worst-case scenarios have nothing to do with physical collision, and everything to do with what this visitor might represent? When the James Webb Space Telescope turned its infrared gaze to 3I Atlas on August 6th, it revealed something extraordinary. The comet's coma wasn't dominated by water vapor, as is typical, but by carbon dioxide. The CO2-to-water ratio was approximately 8:1. This wasn't just unusual. It was unprecedented in the history of cometary observation. Typical comets follow predictable scripts. Water ice dominates, sublimating at modest temperatures to create the classic cometary coma, mixed with dust. Other compounds like carbon monoxide appear, followed by carbon dioxide and trace compounds. These molecular ratios tell stories of formation conditions and evolutionary history. Yet 3I Atlas has thrown that script out the airlock. It's breathing CO2 as if on an industrial scale. The numbers become even more striking when considering the distance at which this was observed. 3I Atlas was over 3 astronomical units from the Sun, well beyond the orbit of Mars, when Webb captured its spectrum. Most comets show little activity at such distances from the Sun's warmth, yet this object was already producing a detectable CO2-dominated coma extending hundreds of thousands of kilometers from its nucleus. The scientific community has proposed several natural explanations. Perhaps 3I Atlas formed very close to the CO2 snow line in its natal protoplanetary disk. where carbon dioxide ice could preferentially condense. Alternatively, its extreme age and constant bombardment by cosmic rays could have modified its surface chemistry, creating a radiation-processed crust that seals water ice inside while allowing more volatile CO2 to escape. A third scenario involves the development of an insulating dust mantle over geological time, acting like cosmic insulation that prevents water ice from heating while allowing CO2 to percolate out. Yet, the speculative question remains, what if all these natural explanations, however plausible, miss the most unsettling possibility? What if this chemical signature represents something deliberately engineered for purposes we cannot yet comprehend? This isn't entirely without precedent in a broad sense. Comet C/2016 R2 pan-stars also displayed atypical volatile ratios. Such chemical outliers suggest either more diverse comet formation than we assumed or dramatic post-formation processing. But as we approach the realm of pure speculation, what if these anomalies across multiple objects hint at a pattern? A signature that points toward possibilities beyond the comfortable boundaries of natural explanation. Ongoing observations will be key. As solar heating increases on its approach to perihelion, the molecular balance may shift. If water ice lies beneath the CO2-rich surface, we may see its signature emerge. But what if the changing chemical signatures reveal patterns that suggest not random heating, but system activation? What if we are witnessing dormant systems awakening under the sun's influence? Now, we step deliberately across the threshold from established fact into the realm of informed speculation. Everything that follows in this vein should be understood as a thought experiment, a mental journey into what might be, clearly distinguished from what we know. The baseline, as established by NASA, the European Space Agency, and virtually every mainstream astronomical institution, is unchanged. 3I Atlas is a natural cometary visitor. This isn't bureaucratic groupthink. It's the conclusion that best fits the available data. The object displays classic cometary behavior, follows predictable orbital mechanics, and shows spectroscopic signatures consistent with sublimating ices. Occam's razor, that fundamental principle of scientific reasoning, strongly favors the natural explanation. But science has a history of surprises. Pulsars were first detected as mysterious, perfectly regular radio signals, briefly designated LGM for little green men, before being identified as rotating neutron stars. Could 3I Atlas represent another example of nature proving stranger than our initial assumptions? The speculation about artificial origins isn't emerging from a vacuum. Dr. Avi Loeb, the Harvard astrophysicist who gained attention for his unconventional interpretations of Oumuamua, has floated similar possibilities for 3I Atlas. His position, clearly labeled as opinion, suggests we should remain open to the possibility that some interstellar objects might represent technology. This perspective deserves consideration not because it's necessarily correct, but because it illustrates how extraordinary claims should be evaluated. What would constitute convincing evidence for an artificial origin? We would look for signatures that clearly distinguish it from natural objects, coherent radio emissions, structured transmissions that couldn't arise from natural processes, non-gravitational accelerations, changes in velocity that can't be explained by outgassing or that don't correlate with solar heating patterns, engineered light curves, brightness variations that don't follow the predictable patterns of a rotating, outgassing nucleus. So far, none of these artificial signatures have been detected. Radio telescopes have found only the silence of space. Its trajectory follows celestial mechanics without unexplained deviations. Its brightness varies as astronomers would expect. The carbon dioxide dominance, while unusual, does not by itself suggest an artificial origin. Natural processes can account for it. The lessons from Oumuamua are relevant here. What initially seemed inexplicably exotic ultimately proved to have natural explanations. The pattern suggests a valuable approach for evaluating 3I Atlas. Maintain openness to extraordinary possibilities while demanding extraordinary evidence. We now venture into the deepest realm of speculative territory. What follows is a pure thought experiment, a narrative illustrating the profound questions that could emerge if our current assumptions prove inadequate. This narrative draws from the dark forest hypothesis, a concept from science fiction and serious SETI discourse. The idea suggests that advanced civilizations might remain deliberately hidden from one another, operating under the assumption that revealing one's existence could invite predation from even more advanced neighbors. In such a universe, silence is a survival strategy. If we imagine that 3I Atlas represents not a comet, but a reconnaissance probe, the implications would be staggering. It would suggest our solar system is being surveyed by an intelligence capable of engineering objects that can survive for billions of years while remaining virtually indistinguishable from natural phenomena. The very perfection of its disguise would indicate a technological sophistication that dwarfs our own. Consider the engineering requirements. A probe designed to pass for a comet would need to perfectly mimic spectroscopic signatures, outgassing patterns, and light reflection properties. It would need to carry sufficient volatile materials to maintain its disguise, while simultaneously housing sensors, processors, and communication systems. The power requirements for maintaining active systems across interstellar distances and billion-year timescales are formidable, perhaps involving advanced nuclear or even cosmic ray harvesting systems. Let's push this scenario to its dramatic conclusion. Imagine our continued observations begin to reveal anomalies. Radio telescopes detect brief, structured transmissions. This trajectory shows minute but unmistakable course corrections. Then, the trigger moment 3I Atlas begins to deploy secondary objects, smaller probes that separate and take up positions around Venus, Mars, in the asteroid belt. Suddenly, our solar system would host a surveillance network of unknown origin and capability. The question would immediately arise: how should humanity respond? This would become the greatest diplomatic and strategic challenge our species has ever faced. Who has the authority to speak for Earth? The UN? Space agencies? Individual nations? The complexity of achieving global consensus on something so momentous is staggering. The active SETI debate, whether we should transmit signals into space or just listen, would shift from theoretical discussion to immediate practical concern. If 3I Atlas and its probes were actively studying us, our very response, or lack thereof, would become part of the data being collected. Our internal debates would reveal fundamental aspects of human nature and social organization to whatever intelligence was monitoring us. The crisis communication challenges would be extraordinary. How do you inform the global public about alien surveillance systems without triggering panic? How do you maintain scientific objectivity while acknowledging possibilities that exceed our current understanding? The scenario would unfold through emergency expert roundtables and carefully crafted public briefings, all while battling a tidal wave of misinformation and conspiracy theories. Of course, and this bears constant repetition, none of this speculative narrative is supported by current observations. Every measurement continues to support the natural comet hypothesis. The value of this exercise lies not in its probability, but in its illustration of how quickly our cosmic perspective could change if our assumptions proved inadequate. The concept of the Great Filter emerges from one of the most profound questions in science. If the universe should be teeming with intelligent life, why do we see no evidence of it? This is the Fermi paradox. The Great Filter hypothesis suggests that somewhere in the progression from non-living matter to a spacefaring civilization, there exists a step so improbable or so dangerous that virtually all attempts to pass through it fail. In our speculative exploration, we must confront the possibility that 3I Atlas might be a message from intelligences that encountered their own insurmountable barrier. If we imagine 3I Atlas is engineered technology, we must immediately confront the question of its maker's fate. Its apparent age, potentially billions of years, places its origin in the deep past. Human civilization, from its first settlements to today, spans a mere 10,000 years. Our technological era is just centuries old. 3I Atlas, if artificial, would represent technology operational for millions of times longer than our entire civilizational history. This raises profound questions about technological longevity versus biological survival. Perhaps the most haunting possibility is that we might be encountering probes that persist long after their makers have vanished. Cosmic messages in bottles from civilizations that solved interstellar travel but ultimately succumbed to the Great Filter. The engineering itself would be a paradox. Creating technology that remains functional across billion-year timescales would require materials science, energy systems, and software architectures far beyond our comprehension. Such capabilities would seem to offer protection against many potential filters. Yet, if this is their creation and it's the only evidence we see, what terrible fate claimed them? The possibilities are sobering. They might have fallen victim to resource depletion on a galactic scale, or encountered a hostile intelligence. More unsettling still, they might have succumbed to internal contradictions, the same capabilities that allowed interstellar engineering, perhaps enabling forms of warfare or social collapse that proved impossible to control. Alternatively, the Great Filter might not be destruction, but transcendence. Perhaps sufficiently advanced civilizations inevitably transform themselves into forms that are unrecognizable or undetectable to emerging species like ourselves. The discovery of an artificial signature in 3I Atlas would instantly transform these philosophical musings into urgent strategic considerations. It would force us to ask, is the Great Filter behind us, meaning we are one of the first? Or is it ahead of us, waiting to be triggered by our own technological ambition? Enrico Fermi's question echoes through every astronomical discovery. Where is everybody? It takes on new dimensions when we consider interstellar objects like 3I Atlas. Each visitor is a natural experiment, a sample of galactic material. In principle, these wanderers should eventually reveal signatures of technological civilization, engineered materials, artificial isotope ratios, structured objects. Yet so far, all have appeared thoroughly natural. This absence might be telling us something profound. Perhaps truly advanced societies prefer what we might call silent emissaries. If they send probes at all, they are designed to be indistinguishable from natural phenomena. In this scenario, the very sophistication of alien technology renders it invisible to our current detection methods, which are calibrated to recognize obviously artificial signals. So, if 3I Atlas were a concealed probe, what evidence would ultimately reveal its true nature? Narrowband radio emissions. Natural processes produce radio noise across broad frequencies. Artificial transmissions are typically concentrated in narrow, structured bands. SETI has listened for decades and, so far, 3I Atlas has remained radio silent. Unnatural thermal profiles. Natural objects achieve thermal equilibrium with their environment. Artificial objects might display temperature distributions that suggest internal heat sources or active thermal management. Current infrared observations of 3I Atlas show only what is expected from solar heating. Controlled maneuvers. This would be the most definitive evidence. Natural objects follow gravitational paths with minor, chaotic outgassing perturbations. Artificial probes might show clear, intentional course corrections. Precise tracking of 3I Atlas has revealed no such thing. Its path is a smooth, predictable hyperbolic arc. The natural explanation aligns perfectly with our theoretical expectations. Computer simulations suggest that all young planetary systems eject vast amounts of debris. The galaxy should be filled with such nomads. From this perspective, Oumuamua, Borisov, and 3I Atlas are just the leading edge of a vast population. The upcoming Vera Rubin Observatory is expected to detect several of these visitors per year. This provides a statistical answer to the Fermi paradox regarding interstellar objects. If natural, ejected planetesimals outnumber artificial probes by millions to one, then finding the proverbial needle in the haystack becomes a task of extraordinary difficulty. Our current great silence may simply be a function of a vast, natural background against which any artificial signal is yet to be detected. Now we plunge into the realm of pure cinematic speculation, where we suspend multiple scientific principles for the sake of a compelling narrative. What follows is the outermost edge of possibility. Picture this: 3i Atlas isn't a probe, but a delivery system for something far more insidious. Hidden within its icy matrix, microscopic devices, microseeds, lie dormant, awaiting activation by specific environmental triggers. These could be nanotechnological constructs or engineered biological entities designed for pangalactic dispersal. The concept borrows loosely from the panspermia hypothesis, which suggests life could spread between stars via comets. But our speculative scenario goes far beyond passive spreading. These microseeds would be engineered systems, triggered perhaps by the electromagnetic signatures of a technological civilization or by specific solar radiation patterns. The engineering challenges are beyond comprehension. These devices would need to maintain integrity across billions of years, exposed to cosmic radiation and extreme temperatures. They would require power sources that outlast stars and manufacturing capabilities that could bootstrap from raw materials on alien worlds. The strategic implications would be terrifying. A single object could carry trillions of seeds, each capable of establishing a foothold. The invasion would be silent, patient, and undetectable until activation, which might be timed for centuries in the future, when humanity reaches a specific technological threshold. Now, harsh reality intrudes on this fantasy. The conditions 3i Atlas has endured make this virtually impossible. Cosmic radiation would destroy complex molecular structures over million-year timescales, let alone billions. The violent outgassing that makes it visible as a comet would scatter and destroy any microscopic hitchhikers. The extreme dilution factors, both during ejection and across the 170 million mile gap at its closest approach, make it an impossibly inefficient delivery mechanism. Any civilization capable of such engineering would have far more direct and reliable methods at its disposal. This scenario serves one valuable purpose. It illustrates how our imaginations can outpace physical possibility when confronted with cosmic mysteries. Distinguishing between reasonable caution and unfounded speculation is crucial. The real-world response to 3i Atlas has been a testament to the best of human scientific collaboration. Within hours of its discovery, a global network of observatories swung into coordinated action. The Minor Planet Center refined its orbit, NASA's Planetary Defense Coordination Office ruled out any impact risk, and space telescopes like Hubble and Webb received priority scheduling. This response illustrates modern astronomy's efficiency. Discoveries are automatically shared through international networks, and data is made publicly available through archives like the Mikulski Archive for Space Telescopes, democratizing access to this cosmic event. But imagine if our speculative scenarios proved accurate. Suppose we began detecting coherent radio transmissions or controlled maneuvers. How would our institutions handle the most significant discovery in history? Existing frameworks provide some guidance. The International Astronomical Union has protocols for verifying extraordinary claims. The SETI Institute has draft communication plans for a potential first contact. Space agencies have planetary protection procedures, but none were designed for active alien technology within our solar system. The scale of coordination required would be unprecedented. Questions of jurisdiction would be immediate. Which international body has authority? How do you coordinate among nations that may view the discovery as an opportunity or a threat? The political dimensions would be staggering, likely shifting the current culture of scientific transparency toward one of classification and security. The technical challenges would also be humbling. Our spacecraft take years to reach the outer solar system, We have no realistic ability to intercept a fast-moving object like 3I Atlas. Our only practical response might be radio transmission, assuming we could even understand or recognize their communication protocols. Public communication would face an unprecedented test. How do you announce the discovery of alien intelligence without triggering global panic or economic collapse? The careful, measured tone used by space agencies so far would be critically important, yet immensely challenging to maintain. The actual response to 3I Atlas gives reason for optimism. It has emphasized curiosity over fear, investigation over speculation, and international cooperation over competitive secrecy. These values represent humanity's best approach to cosmic mysteries, regardless of their ultimate nature. The investigation of 3I Atlas raises a fundamental question. How do we balance scientific curiosity against hypothetical risks? In this case, the balance has tilted decisively toward curiosity, and for good reason. Current planetary protection protocols are designed for direct sample return missions or spacecraft landing on potentially habitable worlds. They aim to prevent contamination in both directions. But 3I Atlas presents a fundamentally different scenario. Its safe distance of 1.8 astronomical units eliminates any possibility of direct material exchange with Earth. No spacecraft interception is feasible. The containment question is, therefore, largely academic. This safe distance has enabled a remarkably open and collaborative approach. Data from Hubble, Webb, and ground-based observatories has been made publicly available, allowing researchers worldwide to analyze the same evidence. This transparency represents the scientific method at its best, fostering verification and consensus. This openness stands in sharp contrast to the secrecy that would likely characterize a military or intelligence-led response. The scientific community's default to transparency reflects a philosophical commitment to the universal nature of knowledge. The case of 3I Atlas demonstrates that this principle holds, even when studying phenomena that could, in principle, represent our first encounter with non-human intelligence. The information landscape around 3I Atlas also illustrates the challenges of the modern era. While legitimate science propagates rapidly through professional networks, social media algorithms often amplify sensational misinformation and conspiracy theories. The challenge for scientific institutions is to maintain clear, consistent messaging that distinguishes established facts from speculative interpretations. The precedent set by previous discoveries supports continued openness. The LGM pulsar, the WOW signal, and Oumuamua were all studied through transparent collaboration. This approach has consistently led to better science and greater public trust. The democratization of astronomy, where amateur astronomers and citizen scientists contribute valuable data, would be impossible under a containment-focused policy. The journey that brought 3I Atlas to our doorstep spans distances and timescales that challenge human comprehension. Understanding this scale is crucial to grasping its true significance. If it indeed originates from the galactic thick disk, its story began 10 to 12 billion years ago, when the Milky Way was young and chaotic. Our solar system, at 4.6 billion years old, is a relative newcomer. 3I Atlas has potentially been wandering the galaxy for 5 billion years or more. During its journey, Earth witnessed the Cambrian explosion, the rise and fall of the dinosaurs, and the entire span of human civilization, all just a fleeting moment in its multi-billion-year voyage. The distances are equally staggering. Even at its tremendous speed, crossing significant portions of the galaxy requires millions of years. It has likely encountered thousands of stellar systems, each gravitational interaction subtly altering its course in a cosmic game of pinball, gradually accelerating it to its current breakneck speed. This scale also humbles our own presence. Our radio bubble, the sphere of human-made radio signals expanding at the speed of light since Marconi, now spans about 120 light-years. This seems impressive until we realize our galaxy is 100,000 light-years across. Our entire electromagnetic footprint is a tiny, faint whisper in a vast galactic ocean, making it implausible that 3I Atlas was attracted by our signals. The energy realities of interstellar communication further explain the Great Silence. Broadcasting a signal powerful enough to be easily detectable across the galaxy would require energy outputs comparable to a small star. The same physics makes rapid interstellar travel phenomenally expensive. 3I Atlas's natural velocity, achieved through patient gravitational assists, seems a far more plausible model for crossing the void than exotic propulsion. This statistical and physical perspective is crucial. The galaxy should be teeming with trillions of natural wanderers like 3I Atlas. As our telescopes improve, we will find more, building a picture of galactic diversity that is wondrous enough without invoking the artificial. Perhaps the most profound gift 3I Atlas offers is not exotic speculation, but the simple, reassuring fact of its non-threatening passage. In an era of global challenges, there is deep comfort in a cosmic visitor that arrives precisely when predicted, behaves exactly as natural laws dictate, and departs without disrupting a single sunset. This is the triumph of scientific understanding over cosmic anxiety. Within weeks of its discovery, international teams had calculated its trajectory, analyzed its chemistry, and confidently predicted its harmless future. This is human knowledge and cooperation at their finest. The scientific harvest has been immense. Its carbon dioxide-rich chemistry has already challenged and expanded our models of planetary formation. This isn't just academic. It informs the search for habitable worlds around other stars. The institutional response, a seamless coordination of surveys, space telescopes, and ground-based observatories, has demonstrated a remarkable philosophical commitment to shared knowledge. The public engagement surrounding 3I Atlas shows how to communicate complex science. Legitimate institutions have successfully conveyed its unusual properties while clearly stating its natural origin. They have navigated a media environment rife with misinformation by sticking to consistent, evidence-based messaging. The speculation we've engaged in, from alien tech to microseeds, serves a legitimate purpose. It exercises our imagination, forces us to define the line between natural and artificial, and reminds us that the universe may still hold surprises. But its true value lies in its relationship to evidence. The arc of the 3I Atlas investigation, from initial detection through detailed analysis to confident conclusions, is a case study in how science turns mystery into understanding. The promise of future discoveries adds to this hope. The Vera Rubin Observatory will detect dozens more interstellar visitors in the coming decade. Each will be a new cosmic ambassador, expanding our knowledge of the galaxy. The capabilities that enabled the 3I Atlas investigation are only improving. We are getting better at studying the unknown. As 3I Atlas continues its journey outward, fading into the interstellar dark from which it came, we are left with enduring images. Hubble's exquisite portraits of a fuzzy star-like point surrounded by a gossamer CO2 coma. Webb's precise spectral lines, each a word in an ancient chemical language. The serene, predictable arc of its trajectory plotted across our solar system diagrams. There is a profound comfort in this cosmic predictability. While our terrestrial world churns with uncertainty, 3I Atlas follows laws that have governed motion since the universe began. Its departure is scheduled not by human decision, but by fundamental physics. The answer to our central question, what's the worst-case scenario, has proven refreshingly mundane. No catastrophe awaits. No invasion threatens. The worst case in terms of physical threat is nothing at all. But to call this outcome mundane misses its true significance. The fact that we can predict the behavior of an object that has traveled for billions of years from an alien star is one of science's greatest triumphs. The weirdness of 3I Atlas is no less fascinating for being natural. Its chemistry and its possible ancient origin have already reshaped how we think about our galaxy. The speculative scenarios were valuable thought experiments, but the evidence consistently points to a natural universe, a universe that has proven strange and wonderful enough through the ordinary operation of physical laws. The music for this farewell should be contemplative, capturing both the mystery and the comprehensibility of the cosmos. The tone should be one of reflective wonder, not fear. The final message is not about threats, but about the danger of cosmic anxiety, the fear of the unknown. 3i Atlas has shown that such fear can be dispelled by patient observation, careful analysis, and international collaboration. It has been a case study in approaching the unknown with instruments, curiosity, and cooperation. As it fades from view, the silence it leaves behind is not empty, but expectant. We are waiting for the next cosmic messenger, which will surely arrive, carrying new signatures from distant stars, new challenges to our understanding, and new reasons to look up at the stars not with fear, but with a relentless, hopeful curiosity. Good night, Cosmic Messenger. Thank you for the data, the lessons, and the reminder that the universe is far stranger and more wonderful than our earthbound imaginations might suggest. Safe travels on your continued journey through the galaxy.